at a time when the mysteries of the universe were veiled in darkness. One man illuminated the path of science, revealing the fundamental laws that govern the cosmos. Isaac Newton, mathematician, physicist, and philosopher, paved the way for a revolution in our understanding of the natural world. Welcome to the Universal World Explorer. Today, we take you on a journey through the life of the genius who changed everything. Isaac Newton, born on January 4, 1643, in Woolsthorpe, England, Newton's early life was marked by hardship. His father, a prosperous farmer, died 3 months before he was born, and his mother remarried, leaving young Isaac to be raised by his grandmother. Despite these challenges, it was during his youth that Newton's extraordinary curiosity began to take root. At the age of 18, Newton enrolled at Trinity College in Cambridge, where he began his lifelong journey of discovery. While other students focused on classical studies, Newton turned his attention to mathematics, physics, and astronomy. It was here, in the halls of Cambridge, that he would soon set in motion the greatest scientific breakthroughs of all time. Unlike many of his contemporaries, Newton wasn't content with simply accepting established knowledge. His restless intellect led him to challenge and rethink ideas that had remained unquestioned for centuries. With a mind focused on understanding the world around him, Newton would soon begin developing theories that would shape the future of science. One of the most famous moments in science occurred in 1665, when Newton was at home during the plague quarantine. It was here, under the shade of an apple tree, that he allegedly saw an apple fall and began to question, why do objects always fall straight down? That simple observation sparked one of the greatest breakthroughs in physics, the discovery of the law of universal gravitation. Newton realized that the same force that caused the apple to fall to the ground must also govern the motion of celestial bodies in the heavens. In 1687, Newton published his Principia Mathematica, a work that laid down the 3 fundamental laws of motion and the law of gravitation. These laws explained everything, from the motion of a falling apple to the orbits of planets around the sun. Newton's first law of motion: an object in motion will remain in motion unless acted upon by an outside force, brought clarity to the idea of inertia. His second law defined force as the product of mass and acceleration, laying the foundation for classical mechanics. And his third law, every action has an equal and opposite reaction, helped explain how forces interact in nature. While Newton's laws of motion revolutionized physics, his work in mathematics was equally groundbreaking. Around the same time, he developed calculus, a branch of mathematics that would become an essential tool for understanding change and motion in the physical world. Though Leibniz independently developed similar ideas, it was Newton's work that laid the groundwork for modern calculus. Calculus would enable future scientists and engineers to analyze everything from planetary orbits to the forces at play in mechanical systems, cementing Newton's legacy as one of history's greatest mathematicians. Newton was not content with simply understanding the laws of nature. He sought to improve the tools that allowed us to observe them. In 1668, he designed the first practical reflecting telescope, a device that used mirrors rather than lenses to magnify distant objects. This invention revolutionized astronomy by reducing the chromatic aberration found in earlier telescopes. Newton's reflecting telescope provided sharper, clearer images of the stars and planets, and it played a crucial role in the advancement of astronomy for centuries to come. Though Newton is remembered primarily for his scientific achievements, his interests were wide-ranging. He spent much of his life studying alchemy, attempting to unlock the secrets of matter and transformation. Though these pursuits were not scientifically fruitful, they provided him with a wealth of knowledge about chemistry and the physical world. Newton also devoted much of his life to religious and philosophical inquiries. He sought to understand the divine order of the universe, believing that the laws he uncovered were a reflection of a grand, divine design. His works on theology and biblical interpretation, though often overlooked, also had a profound impact on the way humanity understands the intersection of science and faith. Isaac Newton's contributions to science were not just groundbreaking, they were foundational. His laws of motion and universal gravitation dominated our understanding of the physical world for over 300 years. His work laid the foundation for classical mechanics, inspiring generations of scientists and engineers. Though the advent of relativity and quantum mechanics expanded our understanding of the universe, Newton's laws are still in use today, from sending rockets into space to designing complex machines. His intellectual revolution was one that shaped the very future of humanity. Isaac Newton's legacy will endure for centuries. His vision of a universe governed by mathematical laws changed the course of history, allowing humanity to glimpse the infinite wonders of the cosmos. Today, we continue to explore the universe with the tools he gave us, asking the same questions he once asked. Thank you for joining us on this journey through the life of Isaac Newton. Subscribe to the Universal World Explorer for more documentaries on the pioneers who shaped the world we live in. The universe is vast, and our journey through its mysteries is far from over. Keep exploring, keep questioning, and keep discovering.